In this video for section 12.1, we're going to learn a new type of test called Anova. So looking back, in chapter 9, we did hypothesis tests where we looked at the mean of one population and we used one sample Z and one sample T. In chapter 10, we tested hypotheses that involved comparing two population means. We used two sample T and paired T for this. And now in chapter 12, we're going to test hypotheses where we are comparing three or more population means. And so this test is called Anova, which stands for Analysis of Variance. So some examples of when we might use this are if we want to compare 5 major brands of golf balls and see which one has the greatest mean distance off of the tee, or the EPA might want to determine if there's a difference in the average miles per gallon performance of cars manufactured by 3 producers. So both of these examples involve testing a hypothesis where we are comparing more than 2 population means. The first one is 5 means and the second one is 3. So in this section, we're only going to be considering one factor, which is the independent variable, and so this is called one-way ANOVA. If you want to take more than one factor into account, then you can do a different type of ANOVA, which we're not going to get into here. Each population or group that is compared is called a level. So in our examples up here, the golf ball example has 5 levels and the EPA example has 3 levels. The test statistic for an ANOVA is called the F value. Sometimes it's called an F test. You'll see that in the homework. So when we write the null and alternative hypotheses for a one-way ANOVA, they look like this. Our null hypothesis is that mu1 is equal to mu2 is equal to mu3 is equal to however many means we have. And our alternative hypothesis is that at least one of the population means is different from the others. Note that this is not the same thing as mu1 not equal to mu2 not equal to mu3, etc. So you'll see this in the homework, but this is not the same as saying at least one of the population means is different. This is saying that all of the population means are different. None of them are equal to each other. But our alternative hypothesis is not that strong. It's just that at least one of them is different. So it could be that mu1 is equal to mu2, but they're not equal to mu3. That would fall under the alternative hypothesis. So we only need one of the means to be different from the rest, not all of them to be different from each other. So we're going to look at an example. This is the business application problem on page 435. The Chicago Connection Sandwich Company has 4 locations, and they want to know whether people order different amounts on average at one or more of the locations. So they have a random sample of 8 customers taken from each of the 4 locations, and this is the sample data. So we're going to use an alpha of 0.05, and we want to know if we can conclude that the order totals are different for at least one of the locations. So this is the sample data here. One thing that's important about an ANOVA test is that you want to have the same sample size for each of your levels. So we have 4 levels here. Each one is one of the store locations, and we're surveying 8 customers from each. We want that to be the same number. So what we're going to do first is write our null and alternative hypotheses, as usual. So my null hypothesis is going to be that mu1 is equal to mu2 is equal to mu3 is equal to mu4. I can see from my sample means, which are listed here in the table, 2 of the stores have the same sample means, store 2 and store 4. Stores 1 and 3 are slightly different. So the question is are these different enough for me to say that the population, all customers that visit the store, that people spend more at store 2 and store 4, or are they close enough together for me to say that the 4 stores, people spend the same amount at each? So that's what I'm trying to figure out here. 8 customers is not a lot of customers, so it's not a huge sample, but I'm going to figure it out based on the sample data. So my alternative hypothesis is that at least one store has a different mean. It could be that they're all 4 different, or it could be, for example, that 2 and 4 are the same, and maybe 3 is the same as those, or maybe not. Maybe 1 is the same or not. So at least one store has a different mean. So now I'm going to go to Minitab. I have the data entered here. This spreadsheet can be found on Blackboard if you want to follow along. And then what I'm going to do is go to Stat, and now I'm going down to Anova. And then I'm going to click on One Way, which is at the top. I'm going to change this drop-down menu to Response Data are in a separate column for each factor level, because I have a separate column for each store. Then what I need to do is click in this Responses box, and when I click in there, it will bring up the options that I can select in this left-hand box. So here I'm going to select each column that I want to include in the analysis. Now I'm not going to include the customer column because that's just the customer number. It's not data, so I don't want to include it because that's going to mess with my results. But I want to include each of the 4 stores. So I'm going to click on each one and then select it and make sure that they are all in the responses box. Then I can click OK. And here are my results. So I can scroll down here. This analysis of variance table is what I am looking for. In the homework, you're going to often have to enter the F value, which is here, 1.03. And then I also have my p-value of 0.393. So I'm going to write those down. F value 1.03. Now remember, the p-value is what we are really looking for to answer our question, or to tell us whether we are accepting or rejecting the null hypothesis. So 0.393, I believe, yes. Okay, so remember, we are comparing the p-value to the alpha. P is not less than alpha, which in this case is 0.05, but even if it was 0.1, it would not be less than that. So, since P is not less than alpha, I cannot reject the null hypothesis. So I do not have evidence that any of the stores have a different average customer spend amount.